Hello and a very warm welcome to the Parker booth here at Bauma 2025. Parker Hannifin is proud to be the global leader in motion and control technologies. And here at Bauma, the motto of the booth, if you've had a look around, is technology inside that moves your world. And the world is, of course, the world of mobile machinery, these giant machines that we see outside. And Parker technology is the hidden champion inside that helps to move these fantastic machines. Parker is here to fulfill your wildest engineering dreams in the mobile machinery and off-road application space. And I'm delighted for our live talks. We have invited experts from all over the globe to share their insights on 4 key themes that we see driving the industry. And those are the 4 key themes that you'll see here also at the Parker booth. Those are electrification, digitalization, mobile hydraulics, and clean tech. For our next talk, we're going to be focusing on the architecture of mobile machinery and specifically there, how to optimize the hydraulic tank and all the effects that that has, reducing cost, reducing complexity, and improving performance. Don't believe it? Listen to our experts. And so it's my pleasure to introduce our experts. I'll come over to you, gentlemen.
Yes.
All the way from Sweden, our electrification expert here at the Parker booth for Bauma. He leads the application engineering team supporting Parker's largest mobile OEM customers with their electrification projects across Europe. He relishes being at Bauma, as you said, to see all your customers' machines in one place. And there are plenty of examples here, which you'll talk about in a little bit. Very warm welcome to Erik Forsberg.
Thank you.
Thank you. And joining Erik, our hydraulics expert, if I may say so, is here all the way from Finland, where he is systems engineer for hydraulic filtration in the Parker Mobile Growth team. He helps his multinational customers in mobile machinery with hydraulic filtration and tank optimization, the topic that we're talking about now. He's delighted to be at Bauma for the very first time this year. Very warm welcome, Timo Nordfors.
Thank you.
Thank you for joining me. So, Timo, first question for you. Why is it important to optimize the hydraulic tank and the machine architecture? What can your customers expect to gain from doing this?
Well, the first thing which often comes into mind is, of course, the tank size reduction and complexity reduction of the system. But there are also many other topics that we can work with, like the improve of system performance. We can work with the safety of the machine operation. We can work with ease of maintenance and total cost of ownership.
Anything else that you'd like to add to that, Erik?
Yeah,
Space is a major factor you've mentioned a few times.
and coming from the electrification part of things, I would like to add, especially on the electrified machine, this is getting more and more important, of course. So the smaller the tank you have, usually the larger the battery you can get or a larger cabin or whatever. But space is usually a very big constraint.
Okay, so freeing up space for all the design engineers to basically have a fantastic playing field for the rest of the machine, right?
Yes.
But it's not just for battery electric mobile machinery.
This technology applies to
optimizing
all
the hydraulic
machines.
tanks.
It's always a good idea, regardless of it's electric or if it's a
Okay.
diesel-powered machine, for sure.
Okay, fantastic. Why does Parker do this, and why do your customers and machine manufacturers not do this themselves?
Yeah, I like to say that, our customers, they are expert in their machines, and they should focus on what makes their machine really good. What if they are fast, or if they are digging quickly, or are very energy efficient, or small or big. That's the important thing. We, as a supplier of products into their machines, should focus more on the details to make sure that we can enable our customers to fulfill their kind of requirements on the machine level.
Okay, so Parker is helping with your the Parker specialization, and they can focus on the overall design.
Yeah.
Let's start with the hydraulic tank optimization specifically, and then we'll go over to the overall architecture, right, Timo?
Yes.
What kind of benefits can the customer have specifically now from the hydraulic tank optimization?
Well, there are like 3 different main topics we can work with. First is the flow pattern improvement inside the tank. So we can work with reduction of the flow velocity. It helps to spread the oil evenly inside the tank. Air bubbles have more time to raise into surface. Well, talking about the air removal, that's important a topic as well. So we can work. That should help with the machine controllability when there is less air content in the oil. So brings more safe operation, and also cavitation issues. Maybe this could be a solution for those, less corrosion and longer lifetime of system components. Then the flow pattern improvement, oil volume usage. So we make sure that the oil volume inside the tank is effectively in use. There is no dead spots inside the tank where the oil is not flowing. And we can also work with the heat transfer. So make sure that all properties it affects positively in oil aging, and then maybe shorter service intervals and component lifetime.
Okay, thank you, Timo. Give us when you're working with a customer, take us through the process. How does that work? This hydraulic tank optimization
So first we have the consultation phase. We meet up with the customer, have a look at what are their interests, what they want to work with, what they want to achieve. Then we usually start with the flow simulation, so CFD study. It may require multiple iteration rounds, and a final step is then lab and on-site testing. So we have the capability to take the tank into our laboratory and repeat the simulation tests in lab conditions, and we also have a possibility to go to customers on site and repeat the same tests there.
Okay, does it make a difference whether it's in the lab at Parker or on site?
Well, outside you of course you will have the real conditions, so we cannot make those in the lab.
Okay.
But
so would you recommend both?
Yeah.
All
yes,
right, both those methods. Okay. Let's just go back to the consultation phase. What do you see as the main goals of your customers in doing this? What are the, let's say, top 2 things that they usually want to achieve?
Well, I think the main point is to understand that what they really want to achieve. Is it the tank size reduction, or maybe cost reduction for and reduction of complexity in the machine?
And what do you see as the main? I mean, you've done hundreds of projects. What would you say is sort of the main driver for them to do this?
I would say the tank size reduction and also air removal.
Yeah.
In order to reduce cost eventually,
Yes,
and reduce emissions, I presume, as well.
Yes.
Okay. All right.
And the space again. I mean, coming back to the this space, this very very limited space that we have on the machine. That's what we want to try to maximize. Not having a big oil can there in the way for everything. And I think just taking a couple of steps back, looking at how it used to work, or I mean how it usually works, for our machine, our customers, the machine manufacturers, they usually get a space envelope in the machine where they need to fit the tank. And then they fill it with a tank, and that's it.
Yeah.
That's how they do it.
Yeah.
Not so much more thinking than that. And that's fair enough. But we can significantly improve that. That's what we want to do.
Yeah, and smaller tanks means less weight, less fuel consumption, so less emissions, and also you have less oil to dispose when you're doing the oil change.
Yeah.
So continued benefits. Okay. You've mentioned that you're delighted to be here to see your customers' products in action. Can you give us some examples of applications of this that have been successful, maybe some that are even here at Bauma?
Yes, of course I can. Yes. So, I mean, looking at, you can see on the screen, Sandvik, we have been working with a long time in this subject. So, and we have a lot of, or a very strong partnership with them. So they, as they say themselves, and I mean, this is on YouTube and even on the video, you can see on the slider screen here, they always consult us. Sandvik always consult us before they start a new machine project to make sure that we optimize the tank for that particular machine. That's always important. I mean, to be able to optimize the space of space in the machine, to get as much out of it as possible, for sure. And another customer that is actually here on site in Bauma is Volvo, of course. We have been working with the tanks for their compact or mini excavators, where the aim was to get as big cabin as possible. So reducing the space of everything else, that includes the tank, then you get a bigger space, and are very happy with the end result. Hiab is unfortunately not here, but they send their best regards with us. We have been working with them to reduce costs. They had a very complex tank solution on their cranes. Now it's much more cost effective with this kind of optimized tanks that we work with.
Okay, so space, design element, was that for the larger cabin? Was that purely a design and then more comfort for the operator, I presume, to have the larger cabin? And cost. So some great reasons there, great benefits for the customer.
Yeah.
Would you like to add something, Timo? Because these are all your customers too.
Well, we have the Sandvik case here in the shift screen, so you can have a closer look, and we have a short video about this.
Okay, so if we move the shift screen to the hydraulic tank, then there's a video there of the Sandvik example. Is that right? Okay, great.
I think on top of that, I would like to add as well, I mean, one key success factor for us as well has been that, as you can see in this video, Timo here, he's not only here talking to the customers, but he's actually doing the tank optimization and the validation out at the machine, because he's also in the video, of course. To have one person to do that all together, understanding the whole chain, that has been a key success factor for us now.
Okay, well, I'm going to go and take a look at the video then afterwards.
Absolutely.
Timo, see you in action. Right, so moving on from the tank optimization, there are other ways. Which other ways can Parker support machine architecture optimization?
Yeah, I mean, on the kind of same topic, by taking a couple of steps away from the tank, we're also looking at the installation of all the hoses, fittings, and hydraulic valves in the system. This is something we have done quite a lot, taking in a machine or going to see a machine at the customer, going through their complete hose, valve, pipe installation to see where we can find ways to improve it. And there's definitely a lot of, I mean, as I said, the customer should focus on the performance of the machine. What's the unique selling point for their machine? And nobody's going to buy a specific machine just because it has an optimized piping structure or something like that. But that's something we should work with. That's something we can definitely support with and have a lot of experience with as well.
Okay, so you're enabling the customer to take the next step with other optimizations that they want to achieve.
Exactly.
Okay, any examples from applications here in this aspect, Timo?
Yes, so we have done more than 250 of these complexity reduction projects, and one example is a forestry crane. If I'm right, there we were, for instance, able to decrease the number of special fittings by 98%, right?
That is true. So we went from 48 to, or reduced from 48 to 1 special fitting on this forest machine. I mean, I think everybody knows here what that means when you can have standard components instead of have a special component. But that's not all of it. I mean, we managed to also reduce the total hose lengths significantly, all the number of fittings, but also the number of manifolds. We had, at the time when we started, we had 13 manifolds on this machine, and we managed to reduce it to 4. That's going to reduce the complexity. That's going to reduce the cost. That's going to reduce all the effort our customers need to put into it.
Okay, but for my benefit, do spell out the benefit of reducing those special fittings
Oh yeah,
for the customer.
fair enough. I will be happy to do that. So everything is special. If it's a special angle on a bend, for example, on a fitting, everything that is special means that it's something unique for that customer usually, and that means that it's a low volume item, and everybody knows that means high cost usually.
In the manufacturing?
In the manufacturing, and also, of course, the sell price in the end, but also availability, flexibility. So by reducing all of that, we can be safer to say that the price is going to be lower. Also, the availability of product is going to be much easier in that case.
And further down the line, the customer will also have increased maintenance and service costs, I presume, for special fittings, right?
Absolutely. In the end of the day, yes.
Okay. Any final conclusions that you'd like to share with perhaps design engineers, someone in procurement from your customer side?
Well, I would say it's all about the total cost of ownership and saving space for other system components. For instance, in a battery electric machine, where you need space for the batteries and other stuff.
And I think it's important to say that we from Parker, we are here to support this kind of journey that we go through together with the customer, both in the electrification project, but also to optimize their standard machines as they have today. There is a lot we can do, and I mean, we see that all over this place. Looking at machines, we see that there's a lot of things that we can optimize. So there's a lot to do, and we can.
Okay, it must be a tempting playground for you to see all the things you could optimize. Any questions from our audience members? Anything you'd like to know about overall architecture or hydraulic tank optimization from our two experts from Finland and from Sweden? Okay, I would have one final question for you. You mentioned the first step in the process is consultation. What would you say to your customer? What would be the things that they should think about before they come to the consultation? Top three things that you'd like them to consider before they come to you?
Well, I would say the effective usage of the oil volume inside the tank. So that's something they should think. We can then help with the position of the filter and suction and return line channels, and if any baffle plates are needed inside the tank. Yeah.
I think, I mean, that's a kind of must-have requirement. Yeah. So that's something so if they can be clear about that, I think it's much easier. And then they also need to set the boundaries, of course. I mean, we set the boundaries together. I mean, what is the space constraint? What are they trying to achieve? I mean, what is their kind of problems that they have today? Is it heat? Do they have heat generation problems, or do they have aeration problems? I think that's something we discuss on these consultations. Kind of what's their main goal with these? What do they want to achieve? I think that's the most important thing.
Okay, to find that out, then they should come and talk to you here at the Parker booth. Thank you so much for your time, Timo, Erik. Thank you for sharing your insights. Thank you for your attention. Our next talk will be starting at 3 o'clock, and we'll be looking at cybersecurity and software for mobile machinery. Hope to see you again. Thank you, gentlemen.